Weight of a body. Galileo showed that all bodies, whatever their masses, have the same acceleration when they fall freely under the action of gravity. For a freely falling body of mass m, the force of gravity acting on it is given by F is equal to mg, where g is approximately 9.81 meter per second square. If the body is at rest on the Earth's surface, this same force presses it down onto the Earth, and this is the force we call its weight. The weight of a body with respect to the Earth is the force which the body exerts on anything that freely supports it. Hence, the weight of a body in Newton is equal to mg. Weight of a body in a lift. There are very few people who have not traveled in a lift or elevator, so probably everyone is acquainted with the feeling of extra personal weight when the elevator accelerates from rest to attain its steady upward velocity, together with the feeling of lightness when the lift decelerates to rest. A man in a lift or elevator is under the action of two forces. One, his true weight, W is equal to mg, acting vertically downwards. Two, the reaction R of the floor of the elevator on the man acting vertically upward. It is the resultant of these two forces that gives the man the acceleration A. One, when the elevator is at rest or moving at constant velocity. The person's apparent weight is equal to their actual weight. This is because there is no acceleration, so A is equal to 0. The upward normal force from the scale equals the downward force of gravity. R is equal to mg, which is equal to W. There is no unbalanced force on the man. If the man's weight is 700 Newton, the scale records his true weight 700 Newton. 2, when the elevator is accelerating upward, the person feels heavier. The normal force is greater than the force of gravity because the scale must not only support the person's weight, but also provide the upward force needed for acceleration. R is equal to mg plus ma. R is equal to mg plus a in brackets. The man's apparent weight 1000 Newton recorded by the scale is greater than his true weight 700 Newton. 3, when the elevator is accelerating downward, the person feels lighter. The normal force is less than the force of gravity because the elevator downward acceleration assists gravity. R is equal to mg minus ma. R is equal to mg minus a in brackets. The scale on which the man is standing records an apparent weight of 400 Newton that is less than his true weight 700 Newton. 4, when the elevator is in free fall. This happens when the cable of the lift is cut and the person feels completely weightless. In this case, the acceleration A is equal to the acceleration due to gravity g. So the apparent weight becomes R is equal to mg minus mg, which is equal to 0. The man appears to have no weight. In this state of weightlessness, the man and the floor exert no force on each other and the scale records 0. Satellite and weightlessness. People and objects in a satellite orbiting close to the Earth experience apparent weightlessness. This apparent weightlessness is the same as that experienced in a freely falling elevator. This is because the satellite and everything inside it is in constant free fall around the Earth. Since everything falls together, there is no support force acting on the occupant. As a result, astronaut appears to float just like a person in a freely falling elevator. Example, a man of mass 70 kilograms stand on a weighing scale inside a lift. A, what is the reading on the scale when the lift moves upward with an acceleration of 2.0 meter per second square? B, what is the reading on the scale when the lift moves downward with an acceleration of 3.0 meter per second square? C, what will the scale read if the lift cable breaks and the lift goes into free fall? Take G is equal to 9.8 meter per second square. Giving values, mass of the man m is equal to 70 kg. Acceleration due to gravity g is equal to 9.8 meter per second square. A, lift accelerating upward at 2 meter per second square. When the lift accelerates upward, the apparent weight w is equal to mg plus a in bracket. Substituting, w is equal to 70, 9.8 plus 2 in bracket. W is equal to 70 times 11.8. W is equal to 826 Newton. Apparent weight of the man is 826 Newton. The man feels heavier. B, lift accelerating downward at 3 meter per second square. When the lift accelerates downward, the apparent weight is W is equal to mg minus a in bracket. Substituting, W is equal to 70, 9.8 minus 3 in bracket. W is equal to 70 times 6.8. W is equal to 476 Newton. The apparent weight of the man is 476 Newton. The man feels lighter. See, when the lift goes into free fall, the acceleration A is equal to the acceleration due to gravity g. W is equal to mg minus g in bracket. Substituting, W is equal to 70, 9.8 minus 9.8. W is equal to 70 times 0. W is equal to 0. In this case, the person becomes completely weightless. Hope you've gained more clarity in this lesson. I would love to hear from you. And like, share, and subscribe.